Well, I give you just take that one. It's better to start because time flies, and I hope people will prefer us soon from the lunch. We are about to start. If you could mention the European AI Association as well, the deputy president, yes, that's probably better. Yes. You put it here, yeah. Depending which form of document you read. Hello, welcome in this session on the impact of artificial intelligence, challenges and policy responses. It's a great pleasure to have with me four great experts in the field. I will start with Pat Pazari, the Chief Economist and Vice President at Amazon, an economist that had published in the top academic journals, American Economic Review, Journal of Political Economy, Econometrica, and is a real expert on empirical models. And I guess he will discuss also with us some findings of his research. We have Mario Mariniello, Digital Advisor at the European Political Strategy Center of the European Commission, and in the past he was a fellow here at Bruegel. Welcome back. This is the composition of the panelists. We have two economists, but we have also two great computer scientists. We have Clara Neppel, who is a Senior Director at the European Business Operations at IEEE. And we have Barry O'Sullivan, Director of the Insight Center for Data Analytics of the School of Computer Science and IT in the University of College York in Ireland, who is also the Deputy President of European Artificial Intelligence Association. So I will start directly the talks without me presenting, because we have great talks and I'm sure you are looking forward to hear the speakers. Pat, the floor is yours.
Super, thanks. What I'm going to talk about today is less of a policy viewpoint. In my job at Amazon, what I do is I work on software, largely. So I'm a co-leader of a worldwide team that we call Core Artificial Intelligence. So it's a bunch of machine learning, AI, robotics, computer vision, and they throw in some econometricians for fun. And by the way, it's about 60% of our scientists and developers are inside of the EU. I'm going to go visit our Berlin lab right after I get done in Brussels. Okay. There we go. So here's what I'd like to do. I think these technologies are at such an early stage. It's really kind of hard to discuss where they might be 10 or 20 years from now. If I was really good at that, I'd be down in the valley doing venture capital. But what I'd like to do today is really talk about two things. The first is what these technologies look like from inside of the firm. Like when you wake up every day and are told to deploy machine learning, AI, et cetera, what does that look like? I think it's some of the descriptions I read in the press are useful, but it's a lot more nerdy and a lot more incremental than I think people appreciate. And the second thing is we did a little study for fun where we looked at a case study of robot-driven artificial intelligence. So, as was mentioned previously, there's a bunch of data about robotics, but very little about robotics that's aided by something you might call artificial intelligence. So, we did a study within our own firm, and I did this jointly with some folks that are contractors of mine. These guys normally aren't doing policy for me. They're helping me build the systems. Hito Imbens from Stanford, Ali Hortikshu from Chicago, and Jan DeLoker, who sounds like he's moving from Princeton to right up the road. Great. So the first thing I'd like to say is if you read the press, you'd somehow think that data in pumping through software was somehow new. And that's very, very far from the case. When I was a assistant professor at a big West Coast university, I started getting involved as a data hack for the Boston Consulting Group in the late 90s. And the chance to see how firms were using data at the start of the IT wave, I did that up until about 2010 as my consulting gig. And then starting in 2010, I went to work for the person who's now one of our CEOs who runs Worldwide Consumer. So, sorry, I'm just having a lot of trouble with this. Yeah, can you help me move back? Yeah, super. Okay. Not very impressive for a technology executive, is it? Okay, so the first thing I want to say is, the use of data in industry is hardly new. When we were working for clients inside of BCG, we were building models using data inside of software. And at that point, software was replacing things that would be easily standardized, like how you cut an invoice, maybe how you set a price, online advertising, etc. But when you looked inside the software, it was very not very sophisticated in terms of how it would use the data. There'd be what my boss would like to call magic numbers. And when I came in the company, he said, your job is to look in code, and anywhere where you see a number, it was probably made up. An MBA pulled out a spreadsheet, kind of made a best sensible guess, put it in the code. There was an if-then statement, and that would make the decisions for you. What I started to notice within industry is kind of as we came out of the Great Recession, they started to look at that little kernel of the code that would take the data and make a decision and replace it with people who were specialized in terms of using data to make decisions. Instead of, I'll give an example of inventory. It used to be the case, it's so old now I can probably talk about it, that in the US we would, roughly speaking, order every book to the 90th percentile of demand. Why the 90th percentile? Kind of sort of a pretty good guess. But I think we list 25 million unique items. That's certainly not a very optimized or rational decision. They started to put people like me in there to help them use a little bit more sophistication in that. And when I came into the company, I ended up interviewing a ton of people. When we were first building in machine learning, econometricians were some of the only folks that could conduct an interview. So I had like 300 of these guys, and I would have them go up to the whiteboard and be like, tell me about a problem you'd like to solve, but, write down the math. Tell me what you actually do. And as I listened to folks solve problems, I noticed that there was a fairly common, for lack of a better word, recipe. And rather than calling these things artificial intelligence or machine learning, as an economist, what I like to think of what they're really trying to do is, this is sort of trying to use the scientific method within the corporation. It's taking the data and making a purposeful decision using things that people like Savage were talking about in Chicago in the 1950s. So the kind of recipe I would see is, I'd ask people to get up on the whiteboard, tell me what you're doing, and they'd be looking at a problem like operations, search, marketing. And what they would normally do is, if you're going to make a rational decision, that means you've got a number that constitutes success. Like there's something that allows you to rank the outcomes. So we call that a metric. So first of all, you define success as a number. The second thing you do is they go and build a predictive model. So a lot of what you do in machine learning, econometrics, AI, it's you build models that make predictions. Then you put together steps 1 and 2, which is you have a predictive model, you have a measure of success, and you try to optimize the predictive model given those first 2 things. And then after that, you're worried that, well, what if my model was wrong? Or what if what I did had some unintended consequences? So you'd then go do an experiment to see whether your model actually worked when you deployed it in the field. And then you go back to step number 1. And this is sort of what people do day in, day out, is they iterate on systems to try and just make them incrementally better over time. So I wanted to give as an example of this, inventory. So this is a really crucial decision for us. We sort tens of millions of unique items in our warehouses. A typical, even large format retailer in the US might have 50, 100,000 unique products that they carry. So this is a order of magnitude harder. And for each item, you want to figure out how much should we order. And there's some trade-offs that would be made in this decision. Like if you buy too much, then you're going to utilize your capital poorly. You're going to have a lot of product that nobody wants to buy. So that means you have to purchase more buildings, which increase costs. And also, in some cases, like if you buy too many of some item in the spring fashion and then it turns in the summer, you might need to mark it down and do so at a fairly steep rate. On the flip side, if you buy too little, you may disappoint your customers. If people show up and they continuously find things that are out of stock, they may not want to return to your site. So just let me kind of walk you through what this might look like. In a metric, here I like to think of it, I'm an economist, the benefit minus the cost. So there's some short-run effects you might have, like Now, what's your unit profit on it? What were your transportation costs? Is it likely that you're going to have to mark this thing down? Like in apparel, this is very important. Seasonal apparel, there's a very good chance you're going to buy the incorrect things and have to sell it at probably below cost because you made the wrong decisions. On the flip side, you don't only want to look at the short-run things. I think a common mistake people make is they only work with the easy-to-measure things, like optimize for clicks. But these longer-run and indirect effects are there. Like if you treat your customers poorly, just because you can't quantify it in your own stuff doesn't mean they're going to come back. So you need to struggle with with kind of the more indirect and murkier issues. Otherwise, you're just really going to screw up your business. The second thing you're going to do is use a model to take some data and estimate a model. So in inventory, this stuff goes back a long time. The problem in inventory is you need to buy before you know how much you're going to sell. You need to go and cut a purchase order to a vendor. It might take a week or two for that vendor to deliver the product. But you don't know what the customers are going to buy 2 weeks from now. And if you're selling tens of millions of things, that starts to get to be a very difficult prediction problem. So here you want to use the data to try and forecast what customers actually want to purchase. And these forecasts are now done by, when you look at these forecasting problems, they're actually very interesting scientifically. They easily involve like 7 different fields of statistics and machine learning, and we don't know how to put these things together right. We're kind of learning as we go along. Then the third thing you do is you want to make a rational decision. So you've got a metric, you've got a view of how much demand is going to show up. So you want to try and make the best decision possible given your forecast. And this is, in some ways, this is similar to what you do in options or derivative pricing, where you're trying to make a maximizing decision under uncertainty. Although I'll say that the problems you face in supply chain make most derivative pricing problems look simple by comparison. These are very, very hard problems to solve. Then the last thing you're going to do is you're going to run an experiment. I mean, these problems are really hard to solve. The science doesn't really exist in some ways for them. So you might have screwed it up. You might have built a model that looks good when you simulate it in backtest, but may not work in practice. So you may go and take your products and deploy an algorithm that uses, say, a new forecast or a new method on half of them and use the old one on the other half, and then make a comparison between the two. So this allows you to validate whether your model does what you intended to do, and also, importantly, did you have any unintended consequences? Like inside of that metric, we know it's important to deal with these like harder to measure, murkier, long-run things. Suppose we see some evidence that we've failed in an unanticipated direction. That may cause us to want to go back and revisit the types of metrics that we're optimizing for. So just from a business viewpoint, why this is so powerful is this is like a self-improving and self-correcting process. We're trying to make just small, simple, incremental changes to systems that have huge leverage within your corporation. And, you know, I think where the economics really kicks in here is in a given year, maybe you'll make a 50 bip improvement on your bottom line. Maybe you'll grow by 100 bips more on your top line. But now go and compound that out for a decade. This becomes very, very powerful. And this stuff is hard, and it's kind of rolling up your sleeves, trying to make progress on problems that you just know aren't solvable in some ways, but sitting down and grunting through it can give you a very different cost structure and a very different growth rate. And this stuff is, the reason there are advantages to this is like simple rules of thumb are nowhere near close to good enough. These are, it's just kind of like when Black-Scholes came into Wall Street and they found a generation of people in finance, math, even economics made careers by cleaning up pricing mistakes. Similar stuff here. These are things where simple rules of thumb just do not do well. I'd like to make a comment about the economic benefits. And here, I think it's what I'm giving you is hypotheses. So I'm looking at what I'm seeing and trying to do some simple reasoning. Right now, in these technologies, we're a little focused on the tech sector. But if you take like the sales of the tech sector and divide it by GDP, like in the US is 18.5 trillion or so, took the sales of Amazon, Facebook, Google, who have you, divided by that, it's just not really that much. I think where we're going to see the real benefits of these technologies when we write the economic history of this area 20 years from now are the places where the waste is the greatest. Because like what this stuff does is it tries to help you make a more rational decision in places where human beings are sort of notoriously bad. You ask people to make statistical gambles, and the behavioral economists have shown us we're not very good at it. The machines approach it in a far more systematic way. So if I were to look for places where I suspect these tools may be important when we write the history of this era in 20 years, look at trucking. In trucking, you may see the fraction of the capacity of a truck that's being used when you average across the U.S. maybe half or less. That's an incredible amount of waste, right? Like empty space is sort of free. You'll have trucks going from ports to, say, the port of LA to Kansas City, and then drive a deadhead load back. So the ability to use the data to not send trucks around the country empty is a real opportunity for efficiency. A second one I'm very fond of is agriculture. I'm on a board for our business school back in Minnesota, where I'm from. And we have companies there like Cargill, General Mills, hardly tech companies, but they'll say, we need to turn Cargill into a digital company. And the motivation they give is if you look at the waste of food between farm and field, they'll mention statistics like 40 to 60% of that food is wasted. So if you can use more intelligent systems, say that could visually inspect. I was at a food bank the other week. We got a lot of onions. And you open up the bag of onions and you found like 40% of them were rotten, but 60% of them were usable. And the economics of that industry made it unviable to like hand pick every one of those. But suppose that machines could use visual technology to inspect that. That could be really interesting. An example I really like that I think has not been talked about hardly at all is there's a lot of waste in how new products are created. Like when we look at product lines, you'll see half the products will die out in a year. And some of that may be economically rational, like if tastes change in fashion or something could make sense to adapt. But I think a lot of this is mistakes. I think they don't know what the customers want and are doing manufacturing runs for products that people really don't want to buy. And that's just not a good use of resources. I'll give you another one. I think you're just starting to see the start of it is, how about using a little science in HR? Like right now, HR has very little in the way of data and science. If you can use that to improve the retention and productivity of your employees or other metrics that are important to you, there's like zero investment in that right now. So I think some of these are big buckets of GDP. Agriculture, trans, creation of new products. And I think the role of tech companies is, what we're doing is we're taking the technology we use internally and we're putting it onto the cloud. So Amazon, for example, we just hired a top machine learning person, Acemoglu. And this is one of Alex's big things, is he thought he could be more impactful working at Amazon than at Carnegie Mellon in machine learning because he could make that technology widely accessible. Microsoft, Google, and others are going down that direction. And I think the economics push you here because we're pretty small relative to 18.5 trillion of GDP. But the problem of getting rid of irrational decisions, like that can be goodness in many, many places. So I want to give you a quick case study of Amazon and the relationship between robotics, wages, employment, productivity. One neat thing I read from Michael Mandel, who's an economist at the Progressive Policy Institute, is if you think about what's going on in fulfillment, it's creating a new service in retail. Like when I go to the grocery store, I need to drive my car and transit the aisles myself to get the product. And part of what you're getting from e-commerce is that that is supplied as a set of market services. So here's a comparison. I'm going to show you a couple of pictures of kind of the old and new way. We bought a company of integrated called Kiva systems, which is a set of robots we use inside of our fulfillment centers. So traditionally, our fulfillment centers are laid out as big library. We call them libraries of products. So if you look at those gray steel cases, they house products. It's sort of barcoded their location, and people would go out and pick them. With the Kiva, it's in, I'll show you a second picture, it's in much denser storage. So if you look at the proximity of the yellow bins versus the gray ones, there's more density, which means we can use our capital more efficiently and lower our cost structure. And then kind of what happens in practice is, I don't know in the EU whether you have these things called Roombas. You got a little thing that sweeps your floor automatically. The Kiva is almost like a Roomba. So it's like an order will come in, the little Roomba goes under the case in the library, and there's a screw at the top. That screw will lift it off the ground a couple 4 inches. And then what will happen is the Kiva brings the product to the worker. So if you had new product and you needed to stow it, they would the Kivas would kind of march along and you would stow it in this location, or if you're picking it, the Kivas would automatically pick. And I've had a chance to do a bunch of these exercises. It's a much simpler task. I just need to have a product. I know the bin it's in. I just need to locate that. This one is a particular DVD. Let's say. So unsurprisingly, having a Kiva where the product is just coming to you, like with these little Roombas lined up one after one, is going to make you much more productive. So with some of my academic collaborators, we tried to estimate the productivity impacts of this stuff. And roughly speaking, investor relations would not be happy with me if I labeled the y-axes, but roughly speaking, you double the output per hour for these workers. Now, something that was mentioned in the prior talk is just because you have a more productive form of new capital, it's actually ambiguous what happens to labor as well as wages within an industry. It kind of depends upon how supply and demand interact, whether it's a complement or a substitute. So the answers to what will occur will actually be very specific to an industry. But at a high level, if you have a more productive technology, one of three things is going to happen. You're going to pass on some gains in the form of wages to the people who work in your buildings. You're going to be able to have lower prices for your customers, or use it within the firm to book its profits or to engage in future investments. So this was a study done by Michael Mandel, who's an economist at the Progressive Policy Institute. I shouldn't call it a study. It was really just looking up data from the Bureau of Economic Analysis and the Bureau of Labor Statistics. And what he found was for our FC associates, the introduction of these types of technologies played out in a little different way than the sort of apocalyptic scenario. The first is, if you look across retail defined as fulfillment centers, that's our big warehouses, and stores, this is for the US only, net employment has increased when you sum those two up. So a second thing is we actually see wage gains. And these are wage gains for people who have where the qualifications are a high school degree or less. Real median wage gains are really an outlier. So if you look at the by SIC code, the wage statistics, at least a fraction of those gains are being passed on to workers. One thing I should say here is when you talk about creation or destruction of jobs, we have a 4.1, so this was a study in the US, there's 4.1% unemployment rate. Labor markets are operating near capacity, even for blue-collar jobs. My dad and brother are contractors out in the Dakotas building highways. They're like complaining to me the other week they can't find enough workers. So labor markets are reasonably tight in the US. So I take discussions of job creation or destruction when you're operating near full employment. You should think of, if you don't think of this in terms of reallocation across sectors, you're probably not looking at it the right way. So policy implications, as I said, I'm sort of a hack inside the software in the company. I'm not a professional policy person, but let me do just a small amount of economic thinking here. The first thing is, when you look at the diffusion of these technologies, it is incredibly early. The set of companies that use these, somebody from Microsoft was saying this as well, the set of companies that use this deeply is very, very small. Within our own company, we only went on a kind of hiring kick in this area just a few years ago. Anybody who claims a measurable macroeconomic impact currently on this, I think that's really, I'm very, very skeptical of any numbers like that. It's not well enough penetrated. And also because it's new, there's going to be a lot of variance in how these technologies evolve. Like there are startups down in the valley doing lots of different things, and we don't know where they're headed yet. But here are some things that I do think we may know. The first is, as an economist, I kind of believe that if you diffuse rational decision-making through more firms, it's probably going to raise the output of your country. How that plays out in individual labor markets, as the prior talk talked about, or David Autor had a really nice discussion, that sort of depends upon supply, demand, related conditions within those industries. But when you roll it up to a macro level, I think you'd have to tell a fairly perverse story in which systematically making better decisions lowers your overall output. And then a second thing is these technologies, when you talk about regulation, something that might just be worthwhile considering is, I don't think we know the most important positive or negative aspects of these technologies yet. Like, we are just at the early stages. Something I do think we know is the levels of investment in basic research and training look low to me. Like, we have a very difficult time finding people with these types of STEM skills. And this is really an opportunity for Europe. We have, I think I said 60% of our folks are in Europe because you have a great tradition of science and engineering. I mean, this is like, when I go to Germany, that's like the home of Gauss. Also, on a lot of the models we use came from basic research. So I heard a figure the other day that was interesting. Jack Ma's much touted investment in AI of $15 billion. That's the budget of the National Science Foundation. You know, this seems a horseshoes and hand grenades. My hunch is that's a little low. So great. I'll stop there. Thanks for listening.
Thanks so much. I think that was. Can you hear me? It was a very interesting elaboration, not only how an algorithm works, but also what are the efficiency gains that can come into the production. And through these sectoral specific examples, it became more clear. And we also had the chance to get some of your views, preliminary views on the policy. One question. On the steps you presented on algorithms, what is the role of the economist and what is the role of computer scientists there?
This is actually really important. On my direct team, half the people who work for me are software developers. People talk about big data a whole bunch, but I think what you find is it's really misleading. I'm going to go off on a small tangent and I'll get back to the point. For those of you who are trained in statistics, you know that data experiences diminishing returns. There's this thing called the central limit theorem. Like the rate at which our models get better experiences diminishing returns. So people will usually not even build models using all the data. But when you deploy the models, you may need for this thing to work in a real-time environment where you may be evaluating a machine learned model and you don't want the web pages to work absurdly slow. So having close collaboration between the software developers and the scientists, whether they're machine learners, economists, whoever, is super important. And in terms of the tools, a lot of the tools overlap. I wouldn't characterize a lot, maybe my colleagues will disagree, a lot of what goes on in ML and AI I wouldn't characterize it as primitive as what happens in math and statistics. Like, we tend to be more practitioners and deployers. So a lot of the toolkits overlap quite a bit, but we're good at different things. Like, I think economists think more about causality. I think we're more fussy about things like metrics. Like, you take these murky, more indirect things that really just can't punt on. We can assist there. I think the ML people are sort of better at scale. I think frequently they're going to find another 200 bips of fit I may not find. They're better at model selection. When I was in grad school, people talked about model selection, but when you have very high dimensional data, it turned out that was super important. I think we have some places where we overlap and some places where we complement, and it's super fun to work in. It's cool stuff.
Indeed. And I will be very happy to hear also your views later on how it is to interact with economists. But before that, I will turn to Mario. Great opportunities, productivity gains. What should we do in the EU?
Well, let's see. Can you hear me? Well, yeah. So thanks a lot. It's always a pleasure to come back here to Bruegel. So thanks, Georgios, for inviting me here. Let me also say that I speak on my behalf. I don't speak on behalf of the European Commission. And everything that I'm going to say today, you can find it on a paper that we just published and is available on our website, the website of the European Political Strategy Center. So from the outset, let me say that I think that artificial intelligence is an amazing opportunity. It's an opportunity for everybody, really, for citizens, for business, for the public sector. And it's an opportunity that we cannot afford not to take. Because if we don't take it, our economy in the long term is doomed to succumb to our international competitors. So I think we need a strategy. A strategy that, from one hand, would foster the development and the uptake of artificial intelligence in Europe. From the other, would address the risks that come with it. Also, I should stress that artificial intelligence markets, they tend to rely very much on economies of scales and network economies. Therefore, often the most suitable level for policy action is supranational. And that explains why it is so important to have a strategy at the European level. It worked. I won't speak about the benefits because Pat was already, very, very clear about that. I would focus actually on where we are in Europe. And I think the first and most important challenge for Europe is with adoption. We don't have good statistics yet for artificial intelligence, but we know that our economy is hardly digitized. Only one fifth of our companies are highly digitized. Only 20% use cloud computing services. Less than 10% of small and medium enterprises do any sort of data analytics. So we are very far from, kind of endorsing fully artificial intelligence in our economy. In terms of supply of artificial intelligence, we are not doing that bad. Our, startup, ecosystem is actually quite fertile and growing, but we still have roughly half the number of companies of United States, and most importantly, our companies fail to ensure the same level of financing that our counterparts in United States and Asia manage to do. So that's a very important problem. Now, when it comes to research, it seems that China is taking the lead worldwide, with more published papers in deep learning than anybody else in the world. Now, you might think, well, what about quality? And in fact, if you control for self-quotation, turns out that China is doing worse than Europe and the US. But you see, China has shown in the past to be able to achieve amazing successes. For example, this is a list of the the best face recognition software in comparison as a percentage error in face recognition. And it's from 2015, but still to make a point. The best one is from Baidu, the Chinese Google. And the third best is from the University of Hong Kong. So that tells something about China. So what do the others have that we don't? I think there are two group of factors that we should identify. First one I would call the usual suspects, issues that we normally talk about a lot. So we don't have still a single market. That's a major problem for us. We lack infrastructure. We lack capital flows. Our companies don't access easily financing. Research can be excellent, but it doesn't really have a straightforward commercial return. So, these kind of issues, and I will discuss also a little bit later. But there is also another important set of factors that is specific to artificial intelligence and relate to what they call the cultural advantage, which boils down to say that in certain contexts, it's easier to play with data because people simply attach a lower value to privacy and personal data. Okay. There was this very, I think, interesting survey by McKinsey made in 2015, which, can you hear me well? Yeah? In 2015, and they asked drivers whether they would be willing to share the location data with manufacturers in order to improve the performance of the car. It turns out that 65% of Germans said yes, 72% of Americans said yes, 93% of Chinese. I think it says something about how easier it is to work with data in China. What is the optimal response to that? I think from one hand, we should create a framework that supports artificial intelligence, and that actually relates very much to what we are doing in the digital single market, which I'm going to go through in a second. On the other hand, and perhaps counterintuitively, I think we should identify and address social risks setting global quality standards. So somehow we shouldn't run after China. We should actually go just on the other hand of the spectrum. That's my idea. And I think we can do that for two reasons. First, because Europe is still the richest market in the world. And so we have some leverage. I think the GDPR in that sense is a good example. And second, digital is really about empowering the single individuals. It's about tailoring everything on them. So if you don't address issues that affect individuals, in the long term you should expect some demand instability, because sooner or later these issues are going to explode. So you might have an advantage in the short term, but in the long term you might pay for it. And I think we also have another good example, which is Cambridge Analytica, right? It exploded now, and we have the GDPR, which somehow, it's now perceived as a very good shield against this type of issues. Now, I won't have the time to delve too much into the harms of artificial intelligence, potential harm, but let me say two things. First, I think the discussion has been a bit hijacked by fears of substitution, which are all legitimate, and I appreciated very much your paper. I think it's very interesting. Yet, I think there is another aspect which is very important, which relates to the augmentation aspect of artificial intelligence. Because if artificial intelligence is empowering individuals to go beyond their limits, it's also kind of exacerbating the power asymmetries that are already in our society. So the gap between those who have power and those who don't have power can increase dramatically because of artificial intelligence. So, in order to make just a simple example, of course we worry about those who lose their job to robots, but we should also worry about how artificial intelligence is going to reshape the relationship between employers and employees. Maybe an employer will be able to just grasp the feelings of an employee by looking at their emails, just scanning the emails, or analyzing the facial expressions of those who they want to hire, right? So it's problematic. And the second point I wanted to make is about discrimination, because that artificial intelligence essentially enable almost perfect discrimination. We could say in the long term this is going to happen, and because of the vast amount of data that are used. And we know that discrimination can be good and bad. Students are discriminated to get discounts in cinemas, but also vulnerable people can be discriminated to pay a higher price for a sickness insurance. So somehow, at the extreme, artificial intelligence can lead to the elimination of the mutualization of risks between members of a society. So it can question the very existence of society in itself. Obviously, it's a very big question that has to be addressed, and I don't have the answer for it. But I know that there are factors that affect the likelihood that discrimination can be harmful. For example, if you have functioning markets, discrimination is less harmful. If you have enough competition in the market, it's less harmful because you somehow, because of competition, you reduce the ability of those who can discriminate to extract value from the customers. But do we have functioning markets? Well, I don't know, but there are good examples out there that suggest that they are not. So if you take, for example, the messaging market, Facebook, because it acquired WhatsApp in the past, has 80% of the market. So, we can get excited about the GDPR, clearly, and all the provisions that are there, like, for example, the meaningful consent. But, the consent is not that meaningful if you don't have a choice. There is just this. There is just WhatsApp somehow. Okay, so, this is an issue. So, what I propose in the paper is a strategy which is based on 4 prongs, which are support, educate, enforce, and human-centric. I won't go into the details of that because you can find them on the paper, and we don't have much time. We're already a bit over time. Just the most important points are here. So I think we need, first of all, to foster the creation of a digital single market. Now, this is a very important point. It's really important because you have a lot of member states that now, are very vocal about the importance of artificial intelligence. But they shouldn't, forget that there is an important link with what is happening on the other, in parallel. So I'm talking about connectivity, ensuring enough investment in broadband and wireless, for example. I'm talking about eliminating barriers that limit data flow within the digital single market, computing facilities, etc., etc. So we need the support of member states also on this. It's not just about injecting money on artificial intelligence. Then stimulate artificial intelligence adoption, because this is going to have like also a pull effect, because it's going to stimulate investment, clearly, and also a multiplier effect, because more digital are companies, more data they will produce, and therefore, more data will be used, feeding in the artificial intelligence, and then make it like more profitable, if you want. Then support research, because we have excellent research, but often our research institutions, they tend to be kind of disconnected from each other. They don't have funding to, the AI labs tend not to scale up. So, we need more coordination at EU level. Invest in skills and education. Actually, somebody mentioned it before. Clearly, skills is actually the most important roadblock to adoption. So we have a number of actions. We can talk about that later. Then the competition policy. Improve our competition policy tools in order to make markets to function properly. And here, for example, I'm referring to merger control. We should be able to capture better in the digital landscape potential competition. So there is a discussion around merger thresholds, which is very relevant, and we should put it in the context of artificial intelligence as well. And then we need an action plan to make the development of artificial intelligence human-centric, which consists of, and then I'm going to close with that. So consists of a number of actions. They're also described in the paper. First, monitoring the evolution of the technology and develop the right metrics for that. Set artificial intelligence quality standards, set the right criteria. I'm going to share the slides, so don't worry, take a picture. Setting the right criteria, like, for example, human in the loop, transparency, lawful by design, these kind of things. Then social system analysis, as it was proposed by Kate Crawford first, which essentially means, analyze the impact that artificial intelligence has in determinate social and economic context, systematically, in a systematic way. Enforcement, meaning, it's not enough to draft an ethical code. We also need to have a clear idea on how we are going to be able to enforce it, maybe through special channels with the relevant authorities. And finally, engage in a global multilateral discussion, because this is actually very important for artificial intelligence. I'm going to stop here because we're already around. Yeah.
Before we move to Clara, just a question for you, Mario. Is there any time pressure to implement this agenda that you presented, or it is something that we should discuss carefully before we move on?
There is time pressure, but first of all, I would say this is the agenda that I proposed in the paper. It's not the agenda of the European Commission. You're going to see next week. The Commission is going to publish a strategy, so that, of course, hopefully some of the things that I proposed are going to be there, but there is a time pressure. However, what is going to be, because we need also to kind of attract investment and give a signal that we want artificial intelligence in Europe, and we will develop the right tools, to address the issues that we see. On the other hand, what is going to happen next week is going to be like a start of a process. It's not, this is obviously, as you mentioned as well, we are excited about artificial intelligence, but we also don't know much. It's somehow, so it's, we want to send the right signals, but at the same time, we also want to have a process of, understanding, really, to stimulate a process of understanding, which, for example, take the form of involving, society at large and all stakeholders in order to contribute to this. Yeah.
It's very challenging to do that at the same time.
Yeah.
Let's see how it will work. Clara, you have this computer scientist background, but you also have some exposure on issues related to patents, innovation. According to you, what are the opportunities and challenges involved?
Well, thank you. I hope this is going to work, so I better stay. I think you mentioned EEE. We tend to say IEEE. It's a little bit easier to say. I think I will just mention quickly, it's like that. Quickly what IEEE stands for. IEEE is the world's largest associations of technologies, so we have more than 400,000 members. I was glad to hear that the other computer scientist on the panel is also a member of IEEE, and we also have some in the audience. So I think what makes it kind of unique is the global reach and the technical breadth. So we have more than 400,000 members worldwide, which are in more than 40 societies, which starting from our historical EE, electrical and electronics engineering, now spanning to quantum computing, ethicists, and so on. We have more than 1,800 conferences worldwide and a lot of publications. And maybe what's also interesting for you, probably everybody, if you are using it, standards, the most prominent one being the Wi-Fi standards, which is also from IEEE, so we are the ones who help developing it. The reason why I'm here is also that we are part of a global public policy and humanitarian efforts, education, and so on. So basically, these whole very different initiatives have one common goal, and that was why I basically joined IEEE last year from the European Patent Office. It is really how to advance technology for the benefit of humanity. This motto basically was even before AI was such a hype. It was really about developing technology, creating standards and industry connections, but also take the responsibility for the technology. So taking now AI as an example, we have, as I said, a lot of publications. Here you have two of our societies who are working there, and conferences. Now, coming to what AI is capable to do. So we heard AI is of course an opportunity. It can solve a lot of societal challenges. But I was asked here to speak specifically about IP. And I will also talk on my personal, as a person, because IEEE doesn't have an IP politic on AI. But I have an opinion on that, and I think the interesting idea is, of course, who will own these technologies? I mean, all these challenges will be solved, and we have a lot of promises there. We already have actually a lot of examples. We have smart lightning posts who talk with vehicles in order to find parking lots, in order to help them not being caught in traffic. We also have, of course, in healthcare, automatic prediction of a heart crisis, of a heart, which will automatically trigger to notify a doctor nearby or even a hospital and so on. But I think it's really interesting to see, so what will happen, who is actually protecting these technologies, what is the IP around it. And of course, IP has a lot of dimensions. One of them is patents, the other at the moment, copyright, trademarks, and so on. So let's look a little bit about the patent system. So because the patent system, I think, is interesting, it's based on a social contract. So what was the social contract, or what is the social contract state? It's basically the inventor donates the disclosure of this invention to the public, so like a new substance which can cure a given disease. And as a compensation, he gets the protection for that. That means he can exclude others using the technology. It's interesting to see it's for 20 years, so it's a very long time scale there. And the disclosure has to be done 18 months after filing. So you can see this was done, of course, at the end of the last century. It was the industrial revolution. It made sense, of course, at that time. What is also important to say, especially for Europe, the invention has to be a technical invention. So you cannot have a protection for abstract ideas. You cannot have the Amazon one-click patent was refused in Europe, for instance. But even you cannot protect any discoveries, any abstract ideas, because that should be left free for everybody to use. Now, if we look to artificial intelligence, and now I'm talking about neural networks, it gets a little bit technical. But basically, it's easy to see. You don't know what's happening inside. You have an input, an output, and basically inside you have a black box. Like, for instance, you as an input, you can have the heart rate, you can have maybe the weather condition. As an output, you can have a prediction if that patient is going to have a heart attack or not. Now, the question is, if that is the disclosure, I personally have at least 2 problems with that. What is the benefit for the public? Can the public, can somebody, another computer scientist, take that disclosure and build another system just like that? So, for instance, if you take the AlphaGo system, if you just said, give us an input, all the Go plays, millions of Go, the outcomes of the plays, and as an output you will have the next move, would you be able to build it? Probably not. And the other thing is this technical effect always achieved? So we just heard that artificial intelligence is an iterative process. Very often, at the beginning, it's less successful. Then you build in some other parameters and so on. It starts to have an increased accuracy. Now, if you give that protection at the beginning, it can have some implications of having unjustified broad monopolies for 20 years. Now, just imagine that somebody came up later on and said, well, beside the heart rate and the weather condition, I will put in maybe traffic data, and I would have a better prediction of the heart attack. Who knows, in Brussels. So this new inventor would have to take a license from the first inventor and could not use the technology if the first inventor would not give him the license. And the other thing about the enabling disclosure, so the black box, as I said, so you have a technology which works with a given accuracy. You give that as a monopoly. Yeah. Let's say that's something similar to what's happening in life sciences as well, because in life sciences you also have a substance which works in 80% of the cases to cure a certain condition. My problem with that again is then you have a well-defined substance which has a certain rate. Here you don't even have the substance which is well-defined. So you have like a black box who is working, well, the black box which is working in 80% of the cases, and you give a monopoly to that. So again, I think it has some societal and economic implications which are important to look at now, because as you also mentioned, Pat, it's the beginning of the technology which is evolving, and if you give that monopolies now, this will have implications on the long term for innovation. The other thing is also on correlation and causality is found by the system itself. So you get a correlation that certain parameters have a certain effect, which is made by the system. So again, it's not a human, which is also normally the patent system is based on a human inventor. So the question is first, who is the inventor? Is it the company? Is it somebody? Who is it a machine? For the moment, we cannot have that. Again, is it an invention or a discovery? Is it a good idea to give a monopoly to that discovery, which might be benefit for the whole mankind? And it's also interesting to think about AI rendering maybe all inventions obvious, because at least the patent system is built on the principle that you get a patent if it's not obvious. And a person skilled in the art can have normal technology. Now, if AI becomes a commonplace technology, you can say everything becomes obvious because you can use AI for that. Here, I just go a little bit and look how could we do better? So can we define this black box better? You can, of course, look into the underlying architecture, and I hope the other computer scientists will go a little bit into that. The underlying architectures, like neural networks, are mostly known. They are open source. They are, as such, not really an enabling disclosure. You can say you would like to see the optimization goals, the training process. Probably that's a good idea. Ultimately, if you want to have a full description of what is there, you might want to have the training data. For the training data, that's we very often hear you cannot disclose that because it's business data, so it's trade secret. And so I even heard the idea we would like to deposit that somewhere and take it out when it's when it's needed. If you would like to look into the weights, which is between the connections, the question is how do you actually protect that? For the moment, we don't even have an IP right for that, because copyright would not be a good idea, because copyright is again based on human creativity. And I think that the most important thing is that self-learning systems change their behavior over time. So what you applied for at the moment that you depose the patent application will change. So the technical effect might change. Again, which is the disclosure for the public, and what consequences does it have for the certification and verification that Mario also mentioned? So IEEE being also a standardization body, that's also very interesting for us. And there are other issues as well. Data and algorithms are basically not to be separated. They are work together. For the data, it's important to see is it valid data. AI systems, which at the moment tend to be standalone, are probably going to be working together. So interoperability is going to be important. Quality was mentioned as well, is make sure that it's inclusive, that it's not biased, and so on. For the algorithms, it's important to have certain transparency, explainability, predictability. And if we talk about IP, we also have to discuss about access rights. And here, it's important to see what is actually the scope of the protection. For what do I have to? I have to get a license, and for what is free for everybody to use. And if we think about the licenses, will we have fair, reasonable, non-discriminatory licenses for data as well? Sometimes, do we have to have compulsory licenses in certain cases? Imagine that you have a pandemic, and somebody would have a big organization deploying AI would have some important data which would be important for the whole mankind. Maybe we will need to have some compulsory licenses there as well. And again, who is going to have a license? Who is going to be able to look into the black box? Is it going to be the certification authority or maybe the public at large? What we heard of the Cambridge Analytica is that Mr. Zuckerberg would like to employ AI to address a lot of issues like fake news and detecting fake accounts. Maybe the public at large would like to look into how he's actually doing that in order to make sure that the society is served. So I think that the right balance is important, and of course you see also the challenges which are addressed by the press, by scientists, and of course also by policymakers. I think that we as a technology and standards association, I think we're very early in detecting that these autonomous systems are something which has a potential to change the society as a whole. So we started 2015 and looked into what ethical, societal, political implications it might have and how we can actually work on that. So some of these, which is called now the Global Initiative on Ethical AI Design, has now 8,800 global experts, and it has some 200 pages of feedback, recommendations, and it's global. So it does not show only the Western world, but also contributions from China, Africa, and so on. A lot of recommendations are for us, for the technologies, so we also have to have this self-reflection, but there are a lot of other recommendations for policymakers as well. And one of the concrete outcomes are already some quality standards that Mario referred to. These standards range from how to make sure that the ethics are taken into account in the design of the systems, so like an ISO 9000 for ethics, for instance, to how to have a personal AI agent, which makes sure that beyond the GDPR, I also have the way to interact with AI on an ongoing basis. and to lay down my terms and conditions, and that these are taken into account automatically, to devising new standards and metrics for artificial intelligence. And here, IEEE and this group is really looking into having new metrics which don't take into account only the economics, the profit, but also the other two pieces, the people and the planet, because we think that AI has really this potential and should also take these two other dimensions into account. Thank you.
Thanks for this nice illustration of open issues. A lot of questions, only a few answers. I will move directly to Barry because we also run out of time. So I notice, if you allow me, I notice in your slide you have also something about explainable AI. I'm very interested in hearing about that.
Very good, okay. Good, so just waiting for the slides to come up. Yes, PDF. Yeah. Oh, there we go. Good. So my name is Barry O'Sullivan. I'm the director of the Insight Centre for Data Analytics in Cork, which nationally in Ireland we have about 420 researchers working in artificial intelligence and data science. I'm also the deputy president of the European AI Association, so we have about 4,500 members across Europe working on AI. So I suppose the big I suppose AI has been around for a long, long time, so I think the term was coined in the 1950s. There have been lots of hype and bust cycles in AI. We're in a hype cycle now, and I suppose one of the questions is, well, what's different about this one than all the previous ones? And I suppose the difference about this one is that artificial intelligence today is really about data. So three things have happened. We have large amounts of data. We share absolutely everything about ourselves. And now that we've realized that we share too much, we're very concerned about that. And so we're all very concerned about privacy, which is all very good and well and good. Cloud computing has become available, so there's massive availability of compute cycles, of powerful methods. And I suppose there have been advances in certain types of AI algorithms that have allowed us to build systems that appear to be super intelligent. So for example, you might have heard of deep learning. And so deep learning, large amounts of data, large amounts of compute, that's basically been the revolution this time around in a sense. That's why you all hear about it. And I suppose as an AI researcher, I'm surprised, I'm delighted, and I'm kind of shocked and afraid that people are so interested in AI because in a way nothing has changed at all. And so I'm kind of wondering what all the commotion is about. I suppose as an AI researcher, I'm very worried about this because I think there's a likelihood that people will overestimate what AI is capable of, and I think when people lose, I suppose their sense of belief in the technology, we'll be in another one of those troughs. So that's one thing I worry about. So just very quickly, what is AI? So, what I noticed is that a lot of people talk about it, very few people actually know anything about it. So I suppose if you read a textbook, it's everything from vision, so how do you get systems to recognize images, recognize faces, and so on? How do you get systems to reason about natural language? Machine learning, big one that we all hear about. Expert systems, they kind of died in the 80s. How do we build robots, which is, I suppose, what we talked about this morning. And I suppose in AI, we tend to talk about robots, which are the things that you expect to be robots. So things that roll around and sort of beep at you. But I suppose they're not, when we talk about AI and robotics in public, we're really talking about automation. And I suppose we need to be careful about the terminology. Are we talking about artificial intelligence? Are we talking about automation? Are we talking about something else? So we need to be careful about that. I suppose I was just mentioning earlier that in Europe we should be very proud of ourselves because we were the catalyst for solving lots of challenges in artificial intelligence. And so the bureaucracy that is, in some sense, the European institutions was very core in solving the language translation problem because the great data set that we produced in Brussels is that every document that we ever produce has to be produced in every language. And so you've got great examples from French to English to German to Spanish and so on. And that data set was enormously valuable, so we should be thankful for that. I suppose artificial intelligence is not just machine learning, is not just deep learning. So these are, deep learning is a particular technique, machine learning is a particular thing. What most people, I suppose today, what most people have talked about when they talk about artificial intelligence is machine learning. And so machine learning is just simply the task of, given some input that is labeled, so for example, we have lots of images of people's lungs, and someone has gone to the trouble of labeling them as that's lung cancer, that's not, that's lung cancer, that's not, that's lung cancer, that's not. The field of machine learning has lots of techniques that then try to figure out, well, if you give me an unlabeled example, can I figure out what it is? And so that's the machine learning task. And in a sense, as most of the economists here will have done line fitting in college, machine learning in a sense is no different from line fitting, except the dimensions are larger. So deep learning is deep because it's function fitting, not in 2 or 3 dimensions, but in billions of dimensions. And it seems to be intelligent because perception problems, perception tasks, those things allow you to recognize things as an expert. So that painting is a fake, that lesion is a particular kind of skin cancer, that's a cyclist on the road. These are basically functions that can be solved using functions that are fitted to millions or maybe billions of dimensions. And since it tells us nothing at all about intelligence. And I like the term artificial stupidity much better. Because when these things fail, they tend to fail beautifully and substantially. And I think we should not lose sight of that. So just because it's artificial intelligence, that's the hope, it's going to be artificial intelligence, but the fun and more interesting cases are when these things are stupid. And so we'll talk a little bit about that in a minute. So just in terms of milestones, just to give you a sort of sense of how things have moved along. So in 1996, Kasparov was beaten by Deep Blue. IBM produced Deep Blue. In a sense, what's fascinating about artificial intelligence is that when we solve a problem, nobody thinks it's intelligent anymore. So nobody now looks back at Deep Blue and says Deep Blue is intelligent. They say it was a big search machine, and it was a big powerful machine at doing search, which it was. Right? So it really tells us nothing at all about the nature of intelligence. But of course, that's not the objective of artificial intelligence. The objective of artificial intelligence is to mimic human expertise in very narrowly defined ways. So, for example, Stephen Hawking, who claimed that AI was an existential threat, that's true in some philosophical sense. But nobody in the field of artificial intelligence is building anything that's going to be an existential threat to humanity. So, really, what we're doing is building, very sophisticated things and automating a very narrowly defined task. And I suppose the AI people call that weak AI. So then in 2007, I suppose what's interesting is we started running Texas Hold'em competitions in the community. And we were interested in this because one of the things we really wanted to be able to do is build AI systems that could fool people that were trying to fool each other, right? So the idea of bluffing. And in 2007, AI was at the point where it could basically beat equally, in some sense, world champions at Texas Hold'em, and No Limit Texas Hold'em is the benchmark in these kinds of applications. In 2017, a colleague of mine, Thomas Santom at CMU, he built a system called Liberatus, which absolutely annihilates every world champion Texas Hold'em player. And it can bluff, it can do everything that a Texas Hold'em player can do. And when you talk to Texas Hold'em players about Liberatus, they will project onto it intelligent capabilities, but of course it isn't intelligent at all, right? In some sense, right? It's an algorithm. It's a set of algorithms. Not to take away from it at all. It's a fantastic achievement. You all heard of Jeopardy? That fell to AI in 2011. AlphaGo fell to AI in 2016. I suppose a couple of things that we need to be careful of when we talk about games and problems falling to AI. So in other words, that AI is now beating the world champion at that game. So the amount of, Clara mentioned, a large number of AlphaGo games. If you plug those into a system, you get an AlphaGo player, which is true. AlphaGo played as much Go as a human being could only achieve if that human being played AlphaGo always, forever, every second of its life, and for 3,500 lifetimes like it. Right, so the amount of game playing that AlphaGo had to do is absolutely superhuman. And so you'd expect, well, if the damn thing can beat a human being after playing more Go games than since before the pyramids were built, then that's not very impressive. And coming back to a second, Liberatus is a system that, yes, it did beat professional Texas Hold'em players, but it required 12 million CPU years to do that, right? So that's a hell of a lot of lifetimes. Okay, so the amount of energy, in fact, required the amount of just power, the electricity bill that came in the letterbox, the Carnegie Mellon, was about $25 million just for the competition to beat these four Texas Hold'em players. So we do have, now, I suppose to put that into context, the thing that's in your skull takes about 7 watts of power. You can't even read 2 pages of a novel under a light that consumes 7 watts of power, right? So when we talk about artificial intelligence replicating and taking over human beings, we have to be very, very careful about what we mean. Absolutely, these systems are powerful, but they're powerful because computing is cheap, data is cheap, and so we're not comparing like with like. So I suppose I'm not dissing AI, my professional career, my salary is paid because I do AI, but I suppose I'm just warning you that when we compare things, we need to be very, very careful about what it is we're actually comparing, right? So moving along. Self-driving cars, fantastic things. I suppose ethically, a few issues thrown up here. Obviously, first of all, the self-driving car revolution is the handiwork of a German, of Sebastian Thrun largely. So Sebastian Thrun is the lead person in self-driving cars. DARPA funded the early work, and of course, DARPA being the defense agency, it wasn't interested really in whether you get your kids to school in the morning. It's interested in military engagement, which is why these things look so super cool as a young boy, and why they've sort of lost their coolness now that they're going to be on roadways. But I suppose it's an interesting thing. The interesting sort of ethical question here is we are lousy at driving cars. We kill, so us and the rest of humanity. We kill about 1.2 million people every year as a consequence of our ability to drive cars because we're drunk, we're texting, we're on the phone, we're sneezing, we're doing stuff we shouldn't be doing in the car while we're driving, and that kills 1.2 million people. Is that a big number? Well, all war, all drugs, all violence on the planet kills about 1.6 million people in the world. So we almost kill as many people as there are on every instance of domestic violence, societal violence, war, drugs, all the bad stuff. We almost kill as many people by driving cars, right? So, and so self-driving cars, yes, they do kill people. We heard an Uber thing kill somebody recently. While that accident was happening, we were probably happily mowing down 100 people, but we don't hear about that, right? So what's interesting about AI is that we often hold technical things to a higher standard than we do ourselves. And so, and it's funny, you hear people saying, "Well, I wouldn't want to be killed by an artificial intelligence system." Why not? Would you really care? After you, So, I suppose one of the big opportunities, and this is something coming back to what Clara said, is the big societal opportunities in artificial intelligence. And I think the Sustainable Development Goals are a beautiful example of the kinds of things that we can actually do. And you might say, well, this all looks like, very interesting stuff, and none of us can disagree with any of these things. These are fantastic objectives. These are the biggest challenges that the world faces. But the question is, how does artificial intelligence address those? And so the UN Global Pulse, for every one of these, is rolling out an AI or data science or data analytics project that demonstrates how technology can address those things. So, for example, just picking one at random, so gender equality. So how can AI sort of address gender equality? And I'll come back to that in a minute as well, because there's more I want to talk about there. So one of the things can be, well, looking at financial transactions to understand, well, how economic shocks impact men versus women. And so, and then that can be used for policy making, for example. And so there's lots and lots of these sorts of things that are interesting. And so the amount of data that's out there is fascinating. But I suppose one thing I do want to say is that, in a sense, the Sustainable Development Goals are addressing developing nations, and lots of developing nations have absolutely no data at all. So in some developing countries, not only do we not know what their sort of economic activity is, we don't even know how many, who has died and who has lived, because there is no data. So we have to sort of think about that carefully. There's a beautiful document called a 100-Year Study on Artificial Intelligence, which I would highly recommend. It's a rather thick report, but kind of fascinating. And it summarizes what's going on in AI and what's been used. I've condensed the whole thing into 2 slides. So basically, there are trends, so the things that people are working in artificial intelligence, and there's the kind of problems that they're addressing. So for example, computer vision, here we're interested in things like visual classification and captioning. So what's happening in this image? So for example, certain very large Asian governments who will remain nameless, but that country who starts, we'll just call the big country that starts in C and ends in INA, they're very interested in monitoring their citizens, right? So one of the big applications that you'll find in deep learning, so the reason that the Chinese are very, very good in deep learning is because they're focusing a lot on this kind of problem. So they want to know what is going on their streets. So it's, surveillance, to some extent. So things like robotics, interested in acting with real world, self-driving cars and so on. The other thing the report does is looks at different domains, so transportation, education, employment and work, and then the kind of questions that are being asked. And so the whole report sort of addresses this. And one of the big questions, I suppose, today, impact of work and jobs. So people in employment and work, one of the things that we're worried about in AI is, well, what kind of impact is what we're doing going to have on labour and so on. And I suppose one of the big things that you don't hear about a lot, and Clara mentioned it briefly, is the whole question of bias. And I call AI systems, I say a bias in, bias out. As a computer scientist, you might have heard something like, well, garbage in, garbage out. I always say that because AI systems today are primarily around data, we really need to understand AI bias. And this is really, really difficult to, this is not just statistical bias. This is not figuring out, is my sample the right sample? It's much more fundamental than that. But so there's a beautiful book that I highly recommend, Weapons of Math Destruction, written by Cathy O'Neill. She has a sort of an unfortunate named blog called mathbabe.org, but that's her own choice, I guess. But it's a great book about how AI can be used negatively to influence and so on, Cambridge Analytica kind of stuff. That doesn't come. I can remember talking about Cambridge Analytica 3 years ago. Nobody cared about it. And in fact, when you look at it, these kinds of systems, they're actually not doing anything different to what they're simply using social media systems in the way the social media systems were designed, right? So, but the big commotion around Cambridge Analytica is simply that it just got the data in a rather underhanded way. But people don't really care. So they don't worry about what they should be worried about, which is the influencing and the micro-targeting and everything else, and that's really sinister stuff. So I suppose just examples of bias. A very scientific experiment around in my office. I Googled Google images for cute babies, and I got a very, very large image that goes on to the floor and beyond. And I think we all agree that most of us will agree that these are cute babies. But it's highly biased output, right? They're all pasty pink, right? So they're all Western, white, wealthy-looking babies, and of course that's not what the world is at all, right? So, and there's a reason, of course, why I got that response. But we should be conscious of why it is that Google tells us the things that it tells us, because it knows where we are, it knows our gender, probably, it knows something about what we like, what we don't like, and that, of course, it customizes the output. Another form of bias, which is very difficult to overcome, is the kind of bias in how we interact, and I suppose specifically how we interact with intelligent systems. We like to break stuff, right? So, and so a few years ago, Microsoft built Tay, and there's a very interesting thing that I think is very sinister in commercial deployments of artificial intelligence. They're usually given female names. And I think this is not just funny, right? I think this is serious. I think Tay is described as female. This robot that we had at the beginning of the day is described as a female. And I think why was that choice taken? Now I have a hypothesis, but I won't actually give it now. You can ask me later. But Tay was basically something that learned by observing how we interacted on Twitter, and there are flames on Twitter, there are people behaving badly on Twitter, and of course people realize that this thing is trying to learn from us, so let's be even more nasty. And so within 18 hours this thing had to be taken down because it was a racist, nymphomaniac, offensive, sort of Trump-esque thing, right? Personalization, which is something that we see often as a feature of intelligent systems, is a form of bias. because we like what we like, and so we get more of it, and we like it more, and we get more of it, and we like it more. And so recommender systems and systems that sort of personalize to us are basically reinforcing our bias, and that can be a very dangerous thing. Now, obviously, there are systems that try to introduce diversity and so on. So, for example, the Amazon recommender is a very good example. It doesn't just recommend what it is that you like, it also gives you some other things that, you know, it doesn't know whether you like or not, which is good. But I suppose, really what's interesting is that natural language is biased. There are baked in gender biases into our own languages. And what I mean is, so this is a science paper published a couple of years ago. And so if you do an analysis of word embeddings, which you can think of as the distance roughly between noun phrases, well, various noun phrases, you'll find that male phrases and powerful descriptions of roles are closer together for men than they are for women. And this is baked into the language. And so if you teach a machine learning system based on just natural language, you can't help but bake in gender bias. And so I have no idea how to overcome that one. We mentioned explainable AI. I'll just briefly talk about that. And I think Clara's points about IP are really interesting. I think artificial intelligence is one of those technologies that can only be described as inherently unsafe. It can never work in the way that we intend it to work because of how we build it. And so we have to accept the fact that when we deploy an AI system, it is inherently unsafe. It will say that you're perfectly healthy when you are not. It will say you're sick when you are not. It will get things wrong. And it's also very easy to hack. This is a nice paper that was published last year where someone went to the trouble of showing that stop signs, that the vision system on a particular self-driving car could be fooled into thinking that these stop signs were 45-mile-an-hour speed limits, which is not the same thing. Right? So for those of you who driving 45 miles an hour and stopping are two totally different things, right? And so these are basically considered as 45-mile-an-hour speed limits. These are images that were very subtly tweaked. You cannot see how they were tweaked because it's really at the individual pixel level. But they're designed to fool deep learning systems. So deep learning systems that thinks that this is an Indian elephant, that this is a sloth, that that's a macaw, and that's a grey fox, of course, which is not correct, right? And the problem is that the AI system can't tell you why it is that they think that they're these things. And so this gets us onto explainable AI, which is and I think this is a fundamental reason why IP legislation is very difficult. If you build a deep learning system to recognize cancer, and you ask the person who built it, why is it so accurate? The only answer they can really actually give you is, I don't actually know. That is the only technical answer today, is I don't know why it works. I know how I built it, I know how I formulated the problem, but I don't know what it is that it actually understands, if anything, about cancer diagnosis. It just seems to work. So that's kind of fundamentally scary. And so there's a lot of work at the moment on trying to make AI systems explainable. So rather than just simply saying that's a cancer diagnosis of a particular kind, you can say, well, why do you think it is? And and understand that even a bit more. And we were talking about the GDPR earlier. I think the GDPR legislation in Europe is a really fantastic piece of AI legislation because it holds a lot of challenges. Maybe not intentionally, but it really challenges AI in lots of interesting ways. So just finally on ethics, I think another big societal thing that we need to get right, very quickly. So job replacement. Obviously, the jobs that are being automated are those that are routine but sophisticated. So things like paralegal assistants, things like understanding cancer diagnoses. These things are easy to automate with artificial intelligence. The question is actually, should we do that? Just because we can, should we? And we actually don't ask that question enough in AI, and I don't think we ask that enough generally. The whole job replacement thing, very, very big question. This is from a very famous article in the US that showed that the most common job in almost every state in the United States is truck driver. We can automate those tomorrow. But what are all those people going to do? Some truck drivers are going to become economists, some are going to become computer scientists, but lots of them are not. So what do we do with those guys? We had a talk this morning about automation. What you find is that that robotic automation tends to occur more frequently in societies that are wealthy. And that's because we're expensive. The people in China, yes, you could possibly automate what they do, but it's not worthwhile. It's just not economically worthwhile. Whereas in Germany, in Japan, and Korea, there are lots of robots because those people are worth actually replacing because they cost a lot. And I suppose, who actually knows what the impact of AI and automation is going to be in job replacement? The numbers are almost random because we don't know. But what we do know is that's going to have an impact. And I suppose the question is then, what are we going to do? Finally, I think just to just connect something that Clara said, can AI invent? I say can. Who is the inventor? It is the AI system. Is the person who built the AI system the inventor? I say no. My mother, she created me, but she does not get her name on any patents that I produce simply because she did so, right? And I think the same is true here, right? I think final slide, what are the top ethical challenges in AI? So unemployment, what happens when we replace jobs? Which creates inequality. So some people get wealthier, some people get poorer. So universal basic income, all these sorts of things. Artificial stupidity, how do we guard against those mistakes? And who is liable for them? And Sophia, the reason Sophia has citizenship is because in order for an AI to be liable, it needs to be a corporate entity. And I think it's interesting that state chose to make that legal citizen that could be targeted as being liable a woman. I think that is a deeply sexist thing. Maybe I'm wrong. Racism, absolutely, as a bias question. What happens when AI goes into adversaries? There are lots of other things. I draw the line here. I'm not so worried about these things, but there are people who actually worry about what happens when robots become sentient, and should we be allowed to turn them off? I think it's a bit too far. I'm not going to stay up worrying about that one. And I don't worry about the singularity, because when we have the singularity, we have immortality, so I don't think we care. Okay, so that's about it. Thank you. Thanks.
We are a little bit out of time, but let's have one round for 2-3 questions. I see a gentleman here and back there. We will take them collectively and then we will conclude in the panel.
Thank you. Fortunately, Martini, a consultant. I was amazed by the slides shown by Mario about the high percentage of drivers who accept that their identity is published. Now, definitely, this should have been before the Facebook scandal. And the big question today, how can we protect the civil side? Because, for example, in France, after the scandal of Facebook, 2 persons on 4 has canceled the subscription to Facebook. There is the monopoly of electricity in France who wants to install an intelligent meter in-house called Linky, and something like 500 communes have refused it because of the intrusion into the social life. So technology today is very dangerous for the people, and artificial intelligence should try to modify and to really protect the individual. So I would like to hear a comment, because this was not really said, and I think it's fundamental that we have to consider this. Thank you.
Thank you. Next question, back there. 2 questions back there, and then we conclude.
Thank you, Mr. Chair. I'm speaking a lot of times for artificial intelligence, and of course we cannot stop the progress, which our movement also supports it a lot. But as we are speaking for robots, and we are very much insisting for Europe to promote robotics, on artificial intelligence we have to be more skeptical. It's very dangerous. It's very dangerous because in Europe, at least, we don't control the internet. The IP has also another meaning. The IP addresses. The IP addresses, they belong to the American military, dressed in an NGO, in the 2 data centers in the West and the East Coast. Nothing belongs to us. So the artificial intelligence, which has the ability of regeneration of the algorithms, as we discussed in the IAA I3E ethical committee some years ago. It has a dangerous of reproducing itself. Already Google on December 2017 made a child, the artificial intelligence of Google made a child in artificial intelligence. So we have our proposition to the citizens of Europe in order to be competitive, our industry, is the creation of the CNET, our own internet. This will create our own intelligence, artificial intelligence, which can compete the American, Chinese, or whatever. Thank you very much.
Thank you. And last question, quick if possible.
Yes, this is to Barry O'Sullivan. Thank you very much. Loved your presentation. And basically, I'd like to give you the chance to explain some of the bits that you sped over towards the end. In particular, you made the comment that the developing world is most at risk. As an economist, I've gotten some ideas of what are the possible channels, but you didn't mention those at all. What you did mention was that robotization is more likely to proceed where labor is more expensive, which is also a valid observation. So just if you could expand, thanks.
Okay. Thank you. So what we will do now is we will merge the answers with the concluding remarks. So we can start with the same turn that we started. Pat, any final comments?
Just a thread in a couple of the comments is around trust. And if you look on our website, it says our goal is to be the Earth's most customer-centric company. And internally we have these things we call tenets, sort of rules you're supposed to use when you build your systems. And one of the main ones is trust is hard to gain and easy to lose. So I think I just know for us internally, acting in ways that are trustworthy, trying to do the right things. You're going to make some fraction mistakes when you're going through very large numbers of decisions, but I think that's something that comes up all the time, and trying to do the right things by your customers. If you read some of the interviews with our CEO, like being trustworthy is good for your business in the long run. It's not bad for your business because people will want to come back when they have a good experience.
Thank you, Pat. Mario?
Yeah, I agree very much with what Pat just said, and thanks for the first question, which I will address now. How do we protect the civil society? Well, I mean, I think, first of all, I mean, what is surprising is that people reacted in that way just after the scandal. Because, I mean, what did you expect? I mean, somehow, I mean, obviously Facebook is, you know, somehow getting something in return. Is making profits in a certain way. So, I mean, you know, people actually, I mean, I realized that a lot of people didn't know that they were paying in some ways for Facebook. They weren't paying a price, they were paying with their own data. So there was a lot of, I mean, I'm not saying that it's a fault of people, but I'm saying there is a problem of really knowledge among, you know, among society about, besides what we can do in terms of direct protection, regulation, GDPR, I think these are helpful. I mean, I think really whatever is your question, the answer is education. We need to, I mean, like, allow people to understand what is going on, because it seems to me that people don't. I mean, they need a big scandal to realize that, you know, this is they are, you know, abusing their data. Somehow, to experts, it wasn't that surprising, but I mean, like, I think that's so. That's the main problem, and I think this, you know. The thing of education is more general. I think you know, it really addresses a lot of issues that we are confronted with in artificial intelligence. If you think about the robots thing, right? It's not just about you know, giving the skills. I mean, like, educating the, you know, people to work with machine. It's also, you know, educate pupils when they are, you know, when they are small, to grow up skills that cannot be replicated by machines. You know, I mean, somehow, you know, we need an overhaul of our educational system, which was, you know, thought for, you know, working at the machines like 100 years ago. And we need actually to build people that are not going to be replaced by machines, but they are going to be completely complementary. Because if you are creative, if you work in group, this kind of things, that exposes to, you know, you much less to be replaced by machines. So that's a very important thing that we should do. Yeah.
Thank you, Mario. So we final remarks on trust, education. Clara, your final.
Yes, well, I would like to comment on, well, coming back to Aristotle, actually. I think that we have a very long definition of what intelligence is, and at least his opinion was that it has three components. One is actually the knowledge, the other is the techniques, and the third one is the wisdom. And actually, we are here in economics. It translates today to the what, how, and why. And the what is clearly with AI, it's a goal that we can achieve. It's the thing that you want to optimize. And the how is done by the system itself. I think it's our role to think about the why and what was mentioned before. Why do we want to do certain things? And I think that it is a societal dialogue between policymaker technologies, but also a public at large for the protection. But it's not. I think we should focus also on the advantages, and I think there is an opportunity there, but these bridges between the different communities have to be built, and they have to be long-lasting. They shouldn't be just an event like this, but it should be consumer protection and so on, a lot of things which have to actually make people aware of what AI is and how they can influence it, how their identity, electronic identity is used, how they can, again, influence that. I think it's a societal dialogue which has to take place.
Thank you, Clara. Barry, quickly, your last.
Yeah. So I'll talk to the development thing maybe afterwards if you've got a couple of minutes. Because I didn't hear the question very well. I suppose just on the question of data privacy, ethics, and I suppose wisdom, the Aristotle question. I suppose what we need is an environment where nobody has valued data. As far as I'm aware, so I know next to nothing about economics, but as I understand it, there's no value attributed to the transaction of me giving data to Facebook. That the more data that a population gives to Facebook, it doesn't reflect, for example, in GDP, as far as I'm aware. But of course, it is actually something that's valuable. But nevertheless, I suppose what we need to do is live in a world where data is seen, where personal data is seen as a liability for companies like Facebook. And so what they should only want to do is take the absolute minimum risk possible by taking the absolute minimum amount of data possible. And that hasn't happened. I think Europe's GDPR, I think, goes part of the way there. And I think it solves a lot of the problems because I think it really puts a huge onus on companies and turns data into a risk. Into a liability for companies, which I think is what we want. On the question of wisdom, I think nothing in AI addresses wisdom, and I think I think what would be a fantastic area of study would be to try and build systems that are not just able to sort of give the sense that they're intelligent or give the sort of illusion of being smart, but actually are wise in some sense. And I think the whole question of wisdom is missing entirely from the AI debate.
Thank you. Let me invite you to thank the speakers for being with us and being patient also with the additional time to spend. My apologies for running the event late. We had some troubles with the delivering lads. Have a nice afternoon.